So welcome to another session on the various topics in pediatric surgery. So today we'll be discussing about a very important topic called neck cysts and sinuses. Now, so there are a wide variety of neck cysts that are noted in children. They can either be acquired or congenital. Most common ones are those which arise from a persistent thyroglossal duct or from brachial anomalies. They may not always be present at birth, mind you. They can manifest themselves at varying age groups, and a careful history and examination is key to identify the type of cyst or a sinus or a fistula. Understanding local anatomy is very important with regard to identifying its etiology, its course, as well as excision. Now, embryology is an essential topic as far as pediatric surgery is concerned because everything that we do has a bit of embryology in it. Actually, not a bit, more than a bit of embryology in it. So it is never more evident than with neck cysts. So neck is a component which has, during evolution, neck has multiple structures developing at the same time. So embryology of the neck is quite complex, to say the least. So let's now briefly discuss regarding the embryology of the neck and its derivatives. Now the neck develops in a developing fetus as an area between the stomatodium as well as the developing pericardium. So this space between the stomatodium and the pericardium elongates or increases to form the neck. This increase is brought about by the descent of the periheart and also by the formation of mesodermal pouches or mesodermal thickenings, which are called as pharyngeal arches. Now, you find that the pharynx, which develops from the cranialmost portion of the foregut, is actually funnel shaped. And funnel shaped, not only is it funnel shaped, it is also compressed. It is compressed dorso-ventrally, that is anteroposteriorly. That's how it's compressed. So it's compressed dorso-ventrally and it has two lateral walls, as you can see here, dorsal surface and a ventral surface. So that's how it is. So this compressed pharynx or upper end of the developing foregut tends to have three important layers. It has an outer ectodermal layer, an endodermal layer, and a middle mesodermal layer. So this mesoderm, this area is formed by the mesoderm. And you have here, this is the endodermal layer and this is the ectodermal layer. So this mesoderm orients itself within the pharynx, developing pharynx, as bars. And this bar extends dorsoventrally. It extends dorsoventrally and it is present in a sequence craniocaudally. So this bar is what forms a pharyngeal arch. So you find that this mesoderm develops from two important components of the mesoderm, that is, it forms from the paraxial mesoderm and the lateral plate mesoderm. So with this regard, so you find that this bar that is present, there are 6 bars that develop. So each of it is called the first arch, the second, the third, fourth, fifth, and the 6th arch. The 5th arch soon disappears after formation. So in the end, we are left with only 5 arches. So these 5 arches are important as they result in the development, or they contribute to the development of many vital structures in the head and neck region. The first and the second arch are the first to develop, and they contribute in no mean terms to the development of the anterior or the closure of the anterior neuropore. So stabilization and closure of the anterior neuropore is also contributed to by the first and second arch. Now, so like I told you, this arch has an endodermal component, which is denoted by red here, and an ectodermal component denoted by blue here, and the green is the mesodermal component. So this endodermal component has outpocketings, which are called as pouches or endodermal pouches or pharyngeal pouches. The ectodermal or the blue areas, like you see here, form depressions called clefts, and these are called ectodermal clefts, also called as pharyngeal branchial clefts or pharyngeal clefts. Now, so as you can see here, in these clefts and pouches are located between pharyngeal arches. So you have first, second, third, and fourth pouches, first, second, third, fourth clefts or pharyngeal clefts. Now each arch, like I told you, each arch is a bar-like structure. So this bar, how it looks like in a coronal section. So if I take each arch and have a look at it, so each arch will have its own nerve, will have a vascular branch from the aorta or an aortic arch, will have a cartilaginous component, will have a skeletal muscle component to it. Now, so the nerve component is different for each arch, and the aortic arch component is also different. So each arch has its own nerve supply, contributes its own nerve, and the muscles which are supplied by this particular nerve, a cartilaginous compound which gives rise to skeletal muscle derivatives, and aortic arch. A very important point to be noted is that the mesoderm that is located, like I told you, between the two ectodermal and endodermal components, this green color mesoderm that you can see here, also has within it neural crest cells. So these neural crest cells contribute to the skeletal component of each and every arch. So coming on to each and every component. Now let's first discuss regarding what are the cartilaginous components. So the cartilage of each arch contributes to various bony elements in the head and neck region. So the cartilage of the first arch is also called mandibular arch. The cartilage of the first arch is called Meckel's cartilage. Now Meckel's cartilage can be divided into two important components. One is a dorsal component and another one is a ventral component. So the dorsal component of the Meckel's cartilage leads on to the formation of the malleus and incus. Those are the small bones in the middle ear, as well as to the wing of the sphenoid bone or spine of the sphenoid bone. So the dorsal aspect of Meckel's cartilage gives rise to the spine of the sphenoid bone, to the incus and malleus, whereas the ventral portion of the Meckel's cartilage is surrounded by mesenchyme to form the mandible.